Welcome to this edition of THUient and Specs. In the last edition, I covered air velocity and flow measurement with pitot tubes. In this edition, I will expand on airflow measurement, covering duct traversing for average air velocity and air volume. The velocity of the airstream in a duct is not uniform over the cross-section of the duct. Friction against the duct walls causes the air velocity to be lower near the sides than the velocity in the center, creating a parabolic velocity profile as shown. Fans, corners, duct fittings, tees, coils, and such all create turbulence in the duct, further changing the velocity over the cross-section. Readings should always be taken with at least 8.5 duct diameters upstream and 1.5 diameters downstream from any device or intrusion that can cause turbulence. Based on these conditions, the air velocity must be averaged over the cross-section of the duct to get an accurate measurement. To get an average air velocity, a formal pattern of sensing points is taken over the duct cross-section, which is known as traverse readings. There are two main patterns for traverse readings: equal area and log linear. For rectangular ducts, using the equal area method, the cross-section is divided into small rectangles of equal area. The velocity is taken at the center point of each of these rectangles and then averaged to get the duct velocity. Using this method, the minimum amount of reading points taken is 16 and the maximum is 64. If less than 64 reading points are being taken, the distance between the points should not be more than 6 inches. In the example shown, 4 holes are drilled into the duct and the pitot tube or anemometer is inserted into each hole to take 4 readings traversing the duct width or height. The reading points are the center of each of the rectangles as shown. For round ducts using the equal area method, the velocity pressure should be taken at the center of equal concentric areas and averaged. In the example shown, 2 holes are drilled in the center line of the duct. 1 set of readings taken vertically and 1 set taken horizontally. If the duct diameter is greater than 14 inches, then use 20 reading points. Between 10 and 14 inches in diameter, use 16 reading points. And if less than 10 inches in diameter, use 10 reading points, with half the points in each reading plane. The reading planes do not have to be vertical and horizontal, but they must be 90 degrees from each other. Use the formulas shown in the diagram for the insertion depth of each reading according to the duct radius. If using a pitot tube, the velocity is directly proportional to the velocity pressure and can be calculated using the formula shown, with V the velocity, D the density of air in the application, and HV the velocity pressure from the measuring device. From velocity, it is then easy to calculate volume flow rate, with flow rate Q equal to the velocity multiplied with the cross-sectional area of the duct. THUient also has an air velocity and flow calculator on our website and downloadable as a mobile application for Apple and Android devices. This calculator will take the velocity pressure and calculate velocity, and with the cross-sectional area will calculate air volume flow rate. It also offers the ability to make air density corrections for humidity levels. For more detailed information, please check ASHRAE, NEB, or AMCA standards. Don't forget to check back weekly for regular editions of THUient and Specs. THUient Instruments, right choice, right price, right now.